discuss a lot of things about building microservices and using a varieties of Java open source softwares and cloud frameworks to achieve that. But before I just jumping into any of the details and stuff, let me just give a quick intro about myself. I'm Saurabh, the practice lead for open source technologies and the cloud solutions here in DVT in South Africa. I love Java programming language. I've always loved it. I've been coding and programming since I was 12. I still love it. And of course, the coffee. The learning mantra for my life to progress forward is staying hungry and staying foolish. That means that always keep on trying to learn something new, keep on improving yourself. Don't be just content with what you think you know, but always be humble enough to learn from everything and everybody, and keep sharing that. I think you should enjoy doing that. That's what is important. Cool. Today we will cover a few things. There is a bit of a theory, but I'll try to show some technical aspects of it also as much as I can. We'll discuss a bit about software architecture and design, why software architecture matters for that sake. And of course, we're going to look into some of the backend application architectures as part of it. And then, of course, we'll discuss and deep dive into the microservices world and see what is happening there and why is it so important, in moving into any kind of software development practices these days. So let's go on to 101 exercise on software architecture. There are many things when people ask them that what is software architecture? You can see some of the things coming up on the screen also over there. My personal favorite one is the last one that just says architecture is about the important stuff, whatever that is. Why so? Because a lot of times we have seen where solution architects and others at various clients in companies and other places, they come up with this brilliant architecture and designs and things like that. Everything looks nice on pen and paper and when you draw it, but the moment when you go onto the reality of doing the work and like stepping into there and building the thing, you start to experience a lot of challenges and problems because of certain sort of unforeseen things, or maybe there's something new that you were not aware of, and now you have to figure it out, saying that, hey, how do I solve this thing, from an engineering aspect, and what else needs to be done? So that's why I've never ever seen, just personally speaking, in my personal capacity and in my personal experience, that anything that has been drawn on pen and paper has exactly and accurately been designed and developed that way. But what I have actually seen is the thing that comes out of the projects when you have very strong teams doing it together, that is far much more amazing and brilliant to what was actually drawn on pen and paper and picture. So exactly, architecture is really about the important stuff, whatever that is, meaning something that really solves your client's problems, or something that helps you build awesome software, and something that you can truly maintain, manage, expand on, and your users, your customers enjoy and love using it. I think that feedback is the most amazing feeling that you can get, something that you have built from scratch or something that you're busy building with your team members and seeing it, how it works. Software architecture, the bigger picture is always about what and where, and it is not about how. It's all about understanding the different kind of architecture styles, the patterns. There are certain trade-offs also that you can look into to see that, okay, fine, how does the storage works? How does something else work? What kind of context are we looking into? And the architect has to do a lot of work upfront in order to understand what could possibly work and what is it that they need to build and where is it that they can build it. There is no coding initially that happens as part of architecture. But that is a bit questionable. Also, we have started to see a lot of proof of concepts being done and designed, even from an architecture perspective, that has to be built just in order to prove that, hey, this architecture can be achieved, even if there is just a small depth of it that you can actually build around it and show your teammates that it is possible. But yeah, that's just in a very niche environment, not necessarily everywhere. What happens in the software design is that it deals with everything to do with how. How are you going to design it? How are you going to write it? How are you going to build it? You have to cover up a lot of things in there in terms of design patterns, your classes, interfaces, functions, responsibility. You have to go into a lot of component and contract level details also if needed be. You have to follow best practices of software engineering, and build this code in a very better way from day one so that the foundation is very clear. You have to follow concepts of clean code, in order to make sure that you don't end up having a lot of bugs or defects into your system, or we'll see something called as crufts. So I'll talk about it in the next slide. So architecture basically is all about what and where, whereas design is all about how. I think it's quite important to remember this as we move along. As I was mentioning about crafts, so you will see, of course, the top portion of the slide over here. If you compare one system with a lot of craft is basically just unnecessary code or bloated code that might have been introduced into your project, into your code base for varieties of reasons. Maybe the developer who was busy writing it didn't have the depth or understanding of the system that they were busy integrating into and ended up writing certain things that was not needed. Maybe the requirements weren't clear. Maybe you didn't have enough time. There are some times when the deadlines are so close for many reasons that you have to sometimes push through and tweak your application in order to achieve something. But the more craft that you keep on adding into your system and into your application, the more problematic it becomes to manage it in longer time and to maintain it in future. And you can't add new features or anything else into it quite quickly because there's a lot of unnecessary code, there's a lot of bloated code that is just messing up with your entire ecosystem. Maybe it is not stable enough, maybe now you can't scale it, maybe there are performance problems that your application is going through, maybe even when your user tries to log in it just takes too long for them to be getting authenticated or authorized to do something. Whereas if you have less or free craft, your application becomes amazing. And yes, there is a way and there are ways of designing and building it this way. And let's see how we can do that. So craft, as I mentioned, is the less craft you have, the less complexity you are introducing into your architecture, into your application. And it is, there's less headache to maintain and manage it. You can remember things quickly. If you don't do that, there are various ways of identifying bad code, which is what code smell is all about. In the Java programming language, there are varieties of code smells that I've mentioned over there. And there are various tools also available to help you understand what is happening, when you write the code, to show you saying that, hey, if you write a piece of code this way, it will introduce so and so kind of a code smell that might affect your code base, that
Saurabh, I think we've lost you. We're no longer hearing your audio. Okay, I think Saurabh is unfortunately disconnected again. So if we can just give him a few minutes to reconnect. It must be the code smells in Blackboard that's causing this.
Also, Prof. Lung, the students that said that if I had to set the test, it would have not gone the same. I disagree. I think my tests were quite easy. It was the same questions over and over again. Do we not agree with that?
Okay,
Yeah.
now do question 1 was confusion of the highest order. We don't know ourselves. That's why I remember when we went through the project management chapter, I said that reflection is very important, that you've got to know yourself. The project management question chapter will always involve, historically at least, will involve questions that ask you to reflect. And so I thought, giving you the 2 marks right at the beginning, just tell me a bit about yourself, was supposed to be, well, Mr. Moodley thought that should be 2 out of 2 for everyone. Unfortunately, some of you did leave it out. I guess it was, you haven't actually thought about your role in your teams or in your projects yet. Also, I just wanted to mention, and for those of you who've done interviews, job interviews already, I think you'll be able to back me up here. But one of the questions that's commonly asked is they do ask you about yourself. And then the other question, the even more difficult question, after going, tell us about yourself. And I know this one, I'm not gonna lie, I struggle with this one, and that is, where do you see yourself in X years? You know, like, where do you see yourself in 5 years? Tell me you didn't get that question. So effectively, I'm doing you guys a favor, you know. I'm doing you guys a solid. I'm helping you prepare for your job interviews. And I thought I'll give you some marks for it. So please do keep reflecting on yourself, because chances are it's going to come up again in the exam. Well, Kay and Yorinda are seeing, as it was an open-ended question, we can get open-ended marks for whatever we wrote, right? As long as it made sense. Well, it needed to make sense in the context of the rest of the table. So if you look at the rest of the table, it told you about your team members. So the information you would write there would have to help contribute to making the full picture. So if you now tell me your hobbies or some other thing, obviously I'm wondering, what does that have to do with helping you use that information to create a team or to rearrange your team, which was actually question 1.2. I will say the following. I thought the one amusing question answer was, someone told me that they were amazing at maths, and then, you know, when I moved further down the question and you know, where the math was involved, you incorrectly added the numbers and gave me 2 hours. So I didn't think you were telling me the truth because of that. Well, you're missing the days when I asked about class and object. That was for some of you 3 years, others 2 years ago. And by then, I'm assuming you have grown. But if you really, really are so keen on this class and object thing, remember that Mr. van der Westhuizen did teach you about integration testing on Monday, and that involved classes and objects. So yeah, you're going to get some more class and objects assessment coming up. Oh, did your third year project have more polymorphism? Well, I don't know. Did you? Well, oh, you know, that would be an interesting question to ask back at this point. Did your project have polymorphism?
Sorry, Prof, you're asking me.
No, MG Delano is asking. I think he's trying to make up. I think he's trying to help me come up with questions for my exam and semester tests.
Okay.
yeah, what is your expected salary and benefits? I think that question really is testing you on your ability to do some research and know what you're getting yourselves into. So in that sense, I would say prepare by taking a look at websites. I don't know, Mr. Moodley, you'll probably be able to offer some of those websites. But they tell you the median, average, et cetera, salaries in certain skill sets. And
Sorry,
it
Prof.
even provides, yeah.
Sorry, Saurabh is back. So yeah.
Oh, wow. Well, okay. Welcome, Saurabh.
He didn't realize he was actually disconnected. So he was
Okay.
presenting
All right.
and presenting, but you know what? So we'll hand over back to him. Let him just try
Okay,
and share his
Saurabh,
screen.
yeah, in case you're wondering where you were last on, you were on the code smells and you were going through all the code smells with us.
Oh, perfect. Thanks, guys. My apologies. I didn't realize there was a problem with the router. Thanks, Evin, for the call. Okay, cool. Let me just share this thing. And okay, guys, are you able to see the shared screen now? Okay, this is quite weird. Sorry, guys, am I audible? Okay, cool. Cool, guys. So I think this is where you guys lost me, isn't it?
Yes, that's correct.
Okay, cool, perfect. So yeah, regarding the code smells, of course, the less craft you have in your application, the less complex it is, and it's easy to maintain and remember what you're doing actually, in your application. Cool. Next, we're going to discuss about the application architecture. A lot of times, people have this question to actually understand. Sorry, guys, there's a bit of a background noise. Am I still audible?
Sorry, Saurabh. Yes, you're still audible. I've muted the offender.
Cool, thanks. Yeah, with regards to the application architecture, a lot of times developers and teams have got this question to say that, okay, what is an application? Where do I start? How do I build it? How do I understand the boundary of my application in terms of what it is supposed to do, what it's intended to do for my customer, and how do I actually start with it? There are various ways that you can identify. I've mentioned 3 things over there on the top. It could be a body of code that the developers see as a single unit of work, and that's what they think an application is. It could be a group of functionality that the business customers see as a single unit, or it could be an initiative, from your investors or someone else who see it as a single budget to say that, hey, this much amount has been set for that particular kind of feature, and that's what we expect it to do, and this is what our customers demand, or that's what they're looking for, and hence why the application has to do that. But at the end of the day, as a developer, as an architect, you always come back to the same question to say that, okay, where does this start and where does this end? Because you can literally build it in any way and in any kind. So I think let's look into the details of how do you define that context, how do you understand that boundary, and what will help you in doing so. So to achieve something like that, it is all about architecture patterns. And there are varieties of architecture patterns available. I'm just mentioning the backend ones over here. You do have architecture patterns for the front end, that you can use for your user interface. It could be a mobile app, it could be a website, it could be any other interface that you're interacting with. So those things can follow different kind of architecture patterns. The ones that I've mentioned over here, well, these are just some of them. There are many others. Even some of these things can be used for your user interface front end architecture patterns. I've mentioned some of the important ones only here, and I've highlighted two of the ones that are always being discussed everywhere. The first one is the multi-tier architecture, or could be a 3-tier and an n-tier, also known as monoliths, or it could be the microservice architecture, also known as just microservices. So I think let's discuss a bit about these two and see what exactly are they. So on the left side of the presentation, you will see details about what's happening in a multi-tier architecture or in a monolith. You have the presentation layer where your user interacts with. Then you have your domain layer, which is what is getting interacted by the presentation layer. This is all about your business domain and what your business ideas or your system or your application is supposed to do. Then it interacts, of course, with your data layer that interacts with maybe an on-prem system, on-prem database or something like that. It could be even as simple as a database installed on your laptop or maybe on your servers or something. Or it can be interacting with something on the cloud in terms of persisting your information or any kind of data that you're dealing with. On the right side, you will see that the same 3-tier can be broken down into a different structure, which can have multiple layers, and it can still have a very basic presentation layer followed by a different kind of domain data pattern that comes in here, where now you have a service layer that interacts with your domain objects, but also interacts with your data mappers. And then the mappers actually interacts with your data access layer, which in turn, performs different kind of create, read, update, delete, basically just the CRUD behavior with your databases. And this can be also one of the representation of the multi-tier architecture or for monoliths. Now, here's this very simple example of a monolith that you have a browser. All the calls from your browser are going through some sort of a web server like Apache, and you have your application server, something like Tomcat, which is running an application like a storefront service or something like that inside it. The WAR file or the WAR detail that you see over there is more from the open source Java part of things. So it's a web artifact because we are provisioning a website or something like that, that you're accessing it via your browser. And your web server is just helping you provision that and pass those information through to your browser, which is your client, or where your client is going to access it from. And in the back end, it is just interacting with a MySQL database for any kind of persisting of information or details. This is a very simple monolith. Now, it looks quite simple, and even though there are some benefits and drawbacks linked to it, I think let's just discuss a bit about the benefits. It's simple to deploy, it's simple to develop. You can scale it, but you have to scale the whole application. Why is it simple to develop? You can see it's a very simple architecture. There's nothing fancy going on in here. So it looks very plain simple. And this is how systems were being built literally like 10, 15 years ago. But now as the complexity of problems are changing and more ideas and concepts are coming in, our internet speeds are becoming better. We have much more better smartphones and technologies and hardwares available now to interact with. So the systems can now do more than what it could use to do 10, 15 years ago. So now people need more feature, more services, much more faster applications to interact with and things to happen quite quickly. So the problem statement is changing, hence why the complexity of designing software is changing. And that's where a lot of new architecture and newer design patterns are going to come and help us. Let's look into some of the drawbacks of the monolith system. It will be difficult to maintain and manage a large code base because you have only one piece of code base and your entire application is built using it. When you have newer developers coming in, they wouldn't know every single portion of that application. So they will be quite intimidated in terms of just making any changes without knowing that, hey, if I go and change this line of code, I don't know what I'm breaking if I don't understand how everything fits together in this big giant monolith. Sometimes it can become quite difficult to understand and modify the code. It can become a bit challenging. I've personally felt it while looking into a lot of systems that were designed like almost 10, 15 years ago, and we have to sit and rewrite a lot of those things into newer architecture, into newer systems. We had a similar sort of confusions and questions that time. Your quality of code starts to decline over time because, again, coming back to the craft, maybe there's a lot of legacy code, maybe there's a lot of unnecessary, unwanted code, and now you're trying to add features and bug fixes within that kind of code base. So nothing is literally happening to your craft, it's just becoming more and more. So that can make your system unstable. whenever you're trying to load it into your development environments, it can become very overloaded. You might have to look into 10 to 20 different projects just to understand that one behavior, to see that, cool, this is how everything fits together. Your startup time can become quite slow because you have to go through so many things. You cannot deploy continuously. What does that mean is you always need to have some sort of a downtime to say that, hey, tomorrow or in Friday afternoon, we are going to do so-and-so upgrades. So please inform all our customers, please inform all our team members that there is a downtime that we have set from 4 o'clock in the morning up until 7 o'clock in the morning, and none of our services will be available, and we'll show a nice, good, pretty picture to our customers saying that service unavailable. I've done that for many of our customers also, and in my personal capacity also a while ago, but things have changed now. Because of better architecture, better design practices, a lot of things can be continuously delivered and deployed into the production environment while you're still using the system as a user, as a customer, without having any kind of downtime. Problems with monoliths are also that you can't scale individual components, meaning I can't go and just pick up one portion. Let's look into this example. If I see that my inventory service is being used the most, or my shipping service is being used the most, I can't go and horizontally scale more of these, meaning I can't just go and say that, hey, in this entire web artifact, I just want my shipping service and my inventory service to be more, as in more instances of them, so that maybe I can access a lot, or my users can access most of those services, and it's available at all times. I can't go and do that in a monolith. I really have to take this entire war because it's packaged together, and then I have to scale it, meaning make multiple copies of it, and then put a load balancer or some sort of balancing in the front for it, so that every time when a call comes in, it can do some sort of routing for me to say that, okay, send this call to the first artifact. Oh, wait, the first artifact is busy right now. Let me send it to the second one, and henceforth. So choosing component level applications or services and then trying to scale it is very difficult in monoliths. And this is something that happens most of the time. And that's where teams and companies come back and say that, hey guys, we have to rewrite this entire thing. This thing is not scaling good for us. Most of our services, like I can give an example for one of the banks, they found out that most of the users are only using the airtime services, from their value-added services to purchase and make quick this thing, buying of airtime through their smart app. But their entire application, which was written in the backend, was a fully packaged monolith. And then they found that users only want to make use of airtime purchase more, so we need to scale that particular service. But they had bundled up a lot of other value-added services, like going and buying prepaid electricity or something else, together into that one application. So it was difficult for them to just break it out and just go and say that, oh, here is my artifact, here is my code base just for buying airtime, and let's just scale it, so that that service is always up and running. So they had a lot of problems, so they had to sit and rewrite the entire system, and they had to re-architect that entire application so that they could scale it better. Another challenge is long-term commitment to a technology stack, and this is happening more and more often now, where you might have picked up a set of technologies thinking that, hey, this is awesome, all our developers know about it, we know that there's good support from the community or from the company that we're buying this product from, and henceforth, and we can use it. A lot of times technology changes, and it always changes. And when newer technology comes in, you always have to sit with legacy code, So hence why you cannot have that kind of long-term commitment built into newer architectures anymore. And monoliths are very much bound to these kind of legacy code. So what basically happens then in your microservice architecture if these are all the drawbacks and problems that monolith has, and now we're saying that, hey, maybe a newer architecture can actually solve those problems. Let's see if it actually does it or not. Now, in a microservice architecture, you will see I have the same account service, inventory service, and a shipping service, but all of them are completely separated from each other, meaning they are not packaged together. That's one thing. Second is all their databases or the entry point to persist their data is actually also sitting just with them. So they directly interact with their own personal databases or their own personal schemas available for their to store their data. At any given instance, if my shipping service has to be called, say, by the account service for some reason, okay, everything has to go via a API gateway, meaning the call from account service goes through the API gateway to say that, hey, route me through to the shipping service so that I can make some sort of call to the shipping service and see what information comes back. And if you see there is a RESTful API, now everything is getting handled through an application programming interface. Now that API layer, there are various ways of designing web services. It could be SOAP-based APIs. If you guys have heard about other distributed frameworks and things like that, something like Corba layer, it used to be very tedious to design services in using those kind of things. Now in the last couple of years, everything has gone through to the RESTful APIs ways, and now in future it's going and moving into the GraphQL or gRPC and other things like that, depending upon how your architecture has to behave and what you need to do. And what is happening now is that for each individual services to interact with each other, they have to go via the API gateway. That's one way of interacting with each other. And if you have your user using the browser, and accessing the storefront web app, then you are also taking out that entire UI code base, your front-end code base also as a separate web artifact, which is also completely independent to your service layer. So you can see now that we have 1, 2, 3, 4 different artifacts available now, doing that exact same thing that was getting done in this one artifact. And now what you can do is, if for any reason you need to expand on your account services and you have to scale it up quickly, you can take that instance and just replicate it like a copy-paste thing. Maybe all those services are still interacting with the same database, that's okay. Or you can just change your routing rules also on your API gateway to say that, hey, maybe for my inventory services only allow so many calls from this time of the day to that time of the day for whatever reason. Maybe that's your business rule, or maybe that's how the domain has to be designed and interacted with. So you can see there are a lot of benefits in the microservice architecture already. This is a full breakdown. So Chris Richardson is the guy who came up with the entire idea about varieties of microservice patterns, and then how they can be used. So in a nutshell, if there's many things happening in here, so you can see on the left-hand side over here, there's application architecture where you have microservices and monoliths. These two things can be swapped around or something depending upon your use case. Then the different layers that you see is the application pattern, the application infrastructure pattern, and the infrastructure patterns. Now, right now, what we're focusing on are the varieties of patterns that defines a microservice architecture. That's very important. So meaning you can go and define an infrastructure pattern that can encompass things like deployment strategy, communication patterns, how your services are going to be getting discovered. Do you have any kind of external APIs that you need to interact with? Or if you're looking into the application infrastructure pattern, then you might need to look into some sort of security stuff or a communication style, or how reliable your APIs have to be. How do you observe your APIs? Meaning what is happening because now if you have so many services available, you have different APIs available, you need to find a way of tracking and tracing to say that, hey, how many times is my account service getting called by the storefront? Or how many times the shipping call is happening? What is going on with my inventory service? You have to gather all these metrics and information. So that's what can happen inside your observability. In your observability, that's part of your application infrastructure pattern. Then you might have some sort of cross-cutting concerns, which are common across multiple services. So you just want to implement something that works for all of them rather than replicating it again and again. You don't want to have redundant code also. Then the last one is the application pattern that actually sees how can you create different kind of data patterns in place, or what kind of database architecture you need to follow. How do you test your application? Where does your user interface sits? So you can see it's a combination of varieties of application patterns, varieties of different kind of design patterns to define how your microservice architecture should actually work. This is just another representation of the same thing from the front, just more in a mind map kind of thing, if that makes sense. Say that, hey, I've got a microservice, architecture available. What happens with my data layer? What happens with my deployment strategy? Is it multi-services that I'm deploying? Is it just a single service that I'm deploying on a single node, or what's going on? Different kind of cross-cutting concerns. How do I test my application and how do I test my services? How do I improve on the matrix and tracking and traceability things? Where does my UI sits? What kind of security do I need to use? How can I make my security thing also, different, and it's not integrated into every single other patterns, or how the different kind of communication has to happen. So all these things are literally working together for your microservice architecture. So there are a lot of benefits to it. I've just jotted down almost all of them, maybe. So I'm just going to go through some of them quickly. You can try different kind of proof of concepts to prove what's happening, as part of your newer technologies. You always have an option of having, maybe, if I just go back, maybe your account services that you built was using Java. Maybe your inventory services, you want to make use of Node.js. Maybe your shipping services is built using .NET. Maybe like something, there's a framework in .NET for .NET Core called Steel Toe. So you can maybe use that to build just your shipping services. So you can have 3 different programming languages doing exactly, doing the domain specific things that you want them to do for your varieties of services, but all of them are supporting your storefront, your web app, which might be written in Angular or React or any kind of other UI programming language. So that's one way of looking into it.
Sorry, Saurabh. If I could just interrupt, Kay Walker does have a question. Would these microservices be hosted on Microsoft Azure?
Oh yeah. So in terms of provisioning them and in terms of hosting them, you can host it in Microsoft Azure, or you can host it anywhere else also. I'll show you some examples of how you can do it on Azure, or how you can even do it on AWS Cloud. If not, then maybe you have an on-prem system and you can even route through all your calls onto the on-prem. So there are varieties of ways where you can deploy them. We have deployed it at some of our clients in a hybrid structure too, or even in a multi-cloud structure. So a multi-cloud structure would be that they are provisioning few things on Google Cloud Platform, maybe just for data mining. They are doing some sort of scaling things on the AWS Cloud, or maybe they are doing some sort of just quick deployment and content delivery management thing from a website static code point of view on Azure. And then maybe on a hybrid model, they have few things still running on premises, maybe like legacy code or something like that, and a lot of their newer stuff is running in the cloud. So yeah, you can deploy it in Azure and any other cloud platforms too. Is there any other questions, guys?
Nothing, but thank you. You've answered it very well for the students.
Oh, let's just look into some of the other benefits also over here. The microservices are relatively small, so it's easy to manage and maintain. You can have a smaller team. You won't need a army of developers over here. You can just have maybe 3 to 4 people in one squad and let them manage and design their microservices and build it. Maybe you have proficient developers, just with .NET skills, and that's what they want to do, and you can just keep on enhancing on your shipping services. Maybe you have Java developers who can build a lot of account services and account-oriented systems, or maybe in future you want to introduce a payment service, that lets you do different kind of payments via Visa or MasterCard or PayPal or anything else. So it's just up to you how you design your system, and of course what budget your team has. It makes, of course, life of the developers more productive, because things are quite fast now. Things are running quicker on your IDEs. You can debug things quickly. Also, it improves a lot of times on your continuous delivery, where you can improve the maintenance of your code. You can test it better. You can deploy it quicker. Everything sounds nice over here. And the last one is very nice: improved fault isolation. Because you have multiple services now available, let's just go back to this example. Imagine I have shipping services, and our team found out that, hey, we need more scaled version of our shipping services. So let's do a horizontal scaling of shipping services, and let's have 5 different instances of it. Out of those 5 instances, even if one dies or one fails over for some reason, none of your other services are going to get affected because of that, because your API gateway can just route to the ones which are up and running. And the one that collapsed for whatever reason, your support team can go and check it out and fix it and then spawn it up again. That's it. So that's why you're isolating that entire thing, where if in a monolith, what used to happen was if one service used to die, your entire system used to just collapse. And then you have to go and figure it out, because nothing is working now and all your clients are facing that challenge of not able to access the system. But not everything is nice and rosy in the microservice world. There are a lot of drawbacks also. And just mention some of them over here. Now that you have so many different services available, you need to find a way for them to coordinate properly and communicate better amongst themselves. Now that you have so many services available, you have to find a way of managing them. You know, if you are taking all these services and spawning them up, like in this architecture, it looks very neat and clean, saying that, hey, I've only got one account service, inventory service, and a shipping service. Imagine if we just went and scaled all of them, 500 to 1,000 times. How would you go and manage them? How would you go and spawn them up quickly? If something fails over, how do you go and pick up that, hey, this was the root cause of the problem? So there are many hiccups and drawbacks also to the microservice architecture. Sometimes debugging can become a challenge because you have to go and do a trace route of what is happening where and then figure it out and see that, okay, if this is exactly happening this way or not. You might find ways where there is increased memory consumption also. But then again, if you have a cloud strategy also as part of your architecture practice and in your process for designing and developing your software, the memory consumption thing is not that big of a challenge. I'll also show you some good examples on how varieties of open source technologies, frameworks, and libraries are actually solving that problem. So we'll look into an example of that also. So not everything is nice and rosy in the microservices world. There are some drawbacks. This is a very good representation of, so Netflix makes use of microservice architecture a lot. In 2009, if I remember correctly, their system was still a bit of a monolith. And as their number of users started to become more and more, and as they went global, outside of the US, expanding into all the other countries across the globe, they found out that their monolith system cannot support so many users, and they were having a lot of fallbacks. Services weren't running and things like that. So in 2009, they decided to re-architect their entire system and build it using microservices. So on the left-hand side, you see a very simplified architecture. On the right-hand side, you actually see the actual architecture. All the green nodes that you see are basically microservices. All the blue lines that you see are varieties of communication and calls amongst each of them in any order, in whichever way the business rules or something has been written. Then, of course, you have varieties of databases and security things and gateways in place. So Netflix had to come up with a lot of newer implementations of their own to define these kind of groundbreaking ideas and building that entire building blocks of a microservice architecture. Now, how do we at DVT, we make use of varieties of open source libraries, platforms, Java in itself, and the cloud ecosystem? This is a clear representation of what actually happens. We have a lot of enterprise-based, foundation-based building blocks, that follows the best practices, clean code, test-driven development work, and many other things, from code analysis to many other things as part of it. Then we have varieties of open source technologies that goes, it can just expand to nth level. There's so many of them. But we focus more on the legacy JEE, the Java Enterprise Edition. Then these two blocks that you see, the Jakarta EE, which is the micro profile, and the microservice ecosystem, which is comprising of Spring, Spring Boot, Cloud, Micronaut, and many others. These two are very important frameworks to actually build varieties of microservices. Then how do we support the entire cloud part of things? Is we still follow everything from the cloud native foundation to define how each of our cloud strategies have to work and what kind of ecosystem that we are going to play around with. It can be depending upon the customer or our clients, where someone comes and says that, hey, we are partially AWS and we are partially Azure. We want to build a solution that works on both of them. Let's build a completely cloud agnostic system. So we have to follow fundamental ideas of cloud native systems or build our microservices following these best practices and the building blocks from the enterprise foundation part of things in such a way that you can really just deploy it and provision it in any kind of cloud environment. It is completely agnostic to their actual implementation. Things have moved much more ahead now with Red Hat Quarkus and few other things to build proper cloud native applications, and I'll show an example to it. And of course, everything follows around over here, follows the DevSecOps, which is development, security, and operations. This entire thing goes hand in hand. Please never ever think that DevSecOps is a role. It's multiple roles with multiple teams, and it's a process in terms of how your team, how your company functions to achieve that process. And these are the building blocks that we tend to use a lot more at DVT for many of our clients. Let's look into some of the Java open source applications, the frameworks, and the cloud-based platform as a service implementations also. I've mentioned some of them over here. Why I'm preferring Java? Because I've been using it for very long. I'm very acquainted with it. But that doesn't mean that you can't go and build microservices in any other programming languages like Python or React or Golang or any other things. You can still do, you can still go and build microservices using them. You just have to follow those same best practices and the entire guidelines of different sort of patterns that defines your microservice architecture, and basically remember this entire mind map to say that doesn't matter what kind of programming language you use, you should have maybe a circuit breaker so that you can communicate properly, or sorry, you should have an API gateway so that you can communicate properly. You should have a way of discovering your services, you know, so meaning your services should be able to register themselves at some sort of a registry so that it can be found properly by the API gateway, and then they can communicate between each other. So this list over here is just exclusive to Java and the cloud solutions that I personally use, or we have used it several times for varieties of reasons and stuff. And these are the much more known ones compared to the other ones. So the first one is, of course, the Spring ecosystem. We'll go into the details of it soon. The second one is around Jakarta and microprofile. Third one is around Micronaut. I've actually used Micronaut for my own personal development work when I built the self-driving car prototype, and I could see how amazing it is when it was running on my Raspberry Pi, driving the car and doing a lot of calculation also to self-drive it. Then you can look into the cloud native part of things, which is from Red Hat called Quarkus. Then, of course, on the cloud part of things, you do have, sorry guys, yeah, of course, on the cloud part of things, you do have AWS cloud implementation and something called as Spring, your Azure Spring Cloud. I'm just emphasizing more on the Azure Spring Cloud because it's a combination of what, it's a very different, it's a very unique platform as a service that has been built by Microsoft, and which allows you to deploy your existing Spring Boot applications, which you might already have running at your client side or something, straight into their Azure system without any kind of code changes, and then still enjoy the power of cloud from Azure. Similar sort of things can be done on your AWS services also, on your Amazon services also. So I think let's deep dive into the Spring ecosystem. Before I go into this thing, guys, do you have any questions, any concerns? I hope.
Yes, Saurabh, thank you. That's perfect, because there have been two questions. Well, yeah, there's actually three questions. Okay. So the one is from Kay Walker. If a microservice collapses, does it get logged in a log file? So that's the first one. You want to answer that, or do you want me to ask the other two questions so you can answer them all in a group?
Let me answer that quickly.
Okay,
so
sure.
That's a very good question. What happens is when your microservice collapses or something happens to it, as part of the observation that you have to do, you will see there's an application logging and an audit logging that's happening also. You always have health checks of your API that is happening, constantly. Because you have so many services talking to each other, you have a distributed tracing pattern built into it also, so that you can easily pick up to say that, hey, service A called service B, C, and then D called B back for some reason, and then something happened with B. All those things can be logged, and you can enable auditing into that. Basically, what happens is all these log files can get dumped into systems like Elasticsearch, which has got a very nice front end called Kibana, and you can go and then do varieties of dashboards and systems built into it to actually pick up these things quite quickly to say that, this is my real problem, that's the root cause, that's why that service died, and here's the logs for it. So you can do that.
Yeah, thank you. And then KN Naidu's question is, when you scale it, I assume it's a microservices up, does each instance created have the exact same data?
Very good question. So when you actually scale it, let's look at this. When you're actually scaling the service, your data is completely independent, okay? So you can go and scale your account service, say 5 times horizontally. So now you have 5 instances of it. All 5 of them can interact with the same database, because that's how you're busy building it, because hold on, accounts details are quite important. You need to understand how credit debit is happening, so that you don't have redundancy of your data, or it's not like some services are going and debiting something while someone else is crediting into it. So your database, as a best practice, as a good suggestion, is that keep it simple, keep it one. So meaning for your one microservice, keep just one instance of that database and let it interact with it. But if for any reason your architecture has to evolve and change into that, then there are different kind of caching behaviors that you can implement in the front of your database, where your other services are actually, or the scaled services are actually interacting with the cache first, then with the actual hot data or the real data. So that's one way of handling it.
All right, thank you, sir. I'm just going to jump around because some of these questions probably you're on the right slide. So how do you test each of these microservices? And as a follow-up, also, how can you communicate with these services using? Can you communicate with these services using SOAP?
Sorry, using SOAP?
Sorry. So the first is, how do you test each of these microservices? And then, as in addition to that, can you communicate with these services using SOAP? So I see you mentioned just REST there. So I think Kay Walker is just asking, is SOAP an option as well?
Yeah, by all means. So you can have SOAP-based APIs. I think I did discuss about it, that I've just mentioned REST over here because that's the most widely used API integration now. But even if you have SOAP services, or even if you have GraphQL-based services, or a remote procedural call, like a gRPC call available, varieties of APIs, any kind of API that you have, following any kind of protocol, you can interact with it. So that's not a problem. So maybe my account service was written in a SOAP-based API. Of course, depending upon what web application I'm using, SOAP calls can become difficult for web applications if you're using JavaScript. But there are libraries which are available also now that can help you integrate and interact with SOAP services. The norm now these days is to make use of RESTful APIs. If not, then move to GraphQL. But yeah, you can make use of SOAP APIs to do so. And I think the first thing that you asked was, how do you test each of these microservices? So from a testing point of view, there are different things that can happen. So I don't know if this thing is quite visible over here on the top right corner for testing. You can have a consumer-driven contract test. You can have a consumer-side contract test. You can have a service component test. So what happens is that each microservice which is exposing something, you can have a contract level testing for it upfront, meaning, and you can build a lot of unit tests as part of your test-driven development work or behavior-driven development work. So just want to show this slide over here quickly. As part of our enterprise foundation and building blocks, you will see there is TDD, which is test-driven development work, which goes and does a lot of testing for single unit of work. And then you have behavior-driven development work, BDD, which is more on the domain part of things. Now, using these two methodologies, you can actually go and test your microservices. You can also do end-to-end automation testing using BDD. And there are certain frameworks like Cucumber and JBehave and Spock that you can make use of to do that testing too.
Okay, thank you. Then there's also Jen Makaza asked, how effective is C# when using microservices?
Okay, cool. So C# hasn't been that successful, and it's got nothing to do with the programming language. It's just how the .NET Core where C# runs properly, was written. That's why now everything has moved to steel toe. So steel toe, the Spring guys, they have created another variant of, away from the Java variant called steel toe. Let me see if I can share my screen and show something to you guys quickly. Okay, guys, I'm just going to stop sharing and then share my entire screen. Please let me know if you guys can see it or not. Okay, are you guys able to see my share screen now?
Not yet. Well, okay, yes, we can see your screen now.
Okay, cool. So there is something called as steel toe. You can make use of now steel toe framework to go and create .NET-based microservices. Steel toe is just another different variant of what Spring provides you. So Spring Boot, Spring Cloud, and in the Spring ecosystem, which is what we'll discuss now. Steel toe is just another variant of it, and it is developed by the same guys who has built Spring, and now they have partnered together and stuff. So you can make use of steel toe to go build microservices, and then make use of the .NET Core framework. Cool.
Okay.
Any more questions?
Yes, one last question there. These questions are endless. I hope it means that you're really engaging the students. No. Yeah, so they're apologizing for being too questiony. So M. Pashwana is asking, what do you use for inter-server communication?
Inter-server communication. Okay. Let me just show. Yeah. So generally what happens is, and I think those questions will be answered in another slide. So can we just hold on to that question, and I'll get back to that question on that slide. I think it will make more sense then.
All right. So one final question. Is GraphQL the initiative Facebook launched, which is an API aimed at connecting its users to one another?
Yeah. So what happened at Facebook was initially they had everything written again using RESTful APIs, and they started to have glitches and problems on their iOS devices for various reasons, because they were making use of Objective-C to build their entire iOS application. And sometimes multi-threading isn't a great thing that happens with Objective-C for some limitations, hence why even Apple has moved on to the Swift programming language now for better multi-threading as part of it. And that's when few of the engineers from Facebook came up with an idea to say that why do we have to keep on making individual RESTful calls, for every single thing? Like if I'm looking at my news feed or something like that, why can't I already have a pre-provisioned data set? Like literally just go and fire a call to say that, hey, give me everything about Saurabh that he likes to see on his news feed. That's it. And then let the user interface or the middleware or the middle layer, actually handles how much of content and what information is to be shown and hidden. And that's how GraphQL was basically built. And yeah, it's a good way of handling these kind of calls. But then again, my personal preference would be only make use of GraphQL if you really have that number or that much amount of data that Facebook has. And if you have to provision that much amount of information to your clients, on a user interface or something, then GraphQL makes sense. Otherwise, you are over-engineering your solution and just making it difficult for your developers to build it.
All right, thank you. Maybe Saurabh, you can continue with your demonstration. Otherwise, I'm worried that you'll run out of time before you get to the good stuff.
Cool. Okay. Cool, guys. So the Spring ecosystem, what can Spring do for you? Of course, we are discussing about microservices, so you can build a lot of things. It follows a lot of reactive designing patterns also, which is related to asynchronous non-blocking architecture. Do go read about it, because there's a lot to cover up in the reactive part of things. Then, of course, you can provision everything into any kind of cloud. If it's AWS, Azure, Google Cloud Platform, Alibaba, you name it. You can build a lot of web applications quite fast and very robust ones quite quickly in the Spring ecosystem. Then you can even go to serverless. Now, serverless doesn't mean that there is no server on which you're provisioning your application or your services. It just means that you don't have to go and manage it. Someone else is managing it for you. It could be your cloud provider, or it could be that application which is providing you that function as a service behavior, basically. It can also help you build a lot of event-driven architecture. So serverless architecture, event-driven architecture, these are different architectures also. In event-driven architecture, you just have a publisher publishing information into some sort of a queue or a topic, and then you have subscribers subscribing to those particular topics or queues and reacting to whatever data comes into those queues. Event-driven architecture has become a lot of, has literally become a norm in terms of what people do these days. So an example would be like, remember Facebook, when you go and just like someone's picture or videos or whatever, or you leave a comment around it, all those things gets dumped into event-driven architecture behavior, where things are written into a queue or a topic, and instantly there are subscribers that read from that particular topic or queue, or just call it as a stream of data basically, and in near real time they provision or process it for you. Then the last one over here that I mentioned is a batch process. There are still systems where certain things only have to happen at that time of the day or that month of that day of the month, and it has to be processed in that way. So hence why the batch processes are still available. How things are working in the Netflix ecosystem, and this is quite amazing. As I was mentioning, in 2009, Netflix decided to re-architect their entire system, follow the entire microservice architecture into their ecosystem. But I think 2011, they had changed everything, and then they started to find problems in managing their entire sources or systems that they had built, like Eureka, Ribbon, Hystrix, and Zool. Each of these ones have got a different behavior, which also falls back to the microservice patterns that we have seen before. Like Eureka is used to do service discovery, and service discovery is needed over here. You can see this particular pattern over here where the discovery block is, where what happens is that on the server side, you need to have some sort of discovery needs to happen. So any service that you create has to come and register itself, to say that, hey, I'm a service called Saurabh, and please register me, so that the next time anyone comes looking for me, my client side systems knows where to look for, so they can go back to the registry. It's like saying, imagine your reception at any of the offices. Now, if someone walks to the DVT reception, they can come and ask me that, hey, I'm here to meet Saurabh, and the reception person would know exactly that, oh, Saurabh sits on the second floor in so-and-so this corner next to this pillar, so that's my address, right? So either the person can then be informed to say that, please go and meet Saurabh over there. So it's like a service registry basically, where you come and ask for something. If the registry has information about you, then it just provides this thing. If not, then it goes and requests or tries to find that particular service. If it doesn't, it comes back to say that, hey, I don't know which this service is or who this particular call is from, and then you handle it accordingly. Cool. Let's move to, and of course, you'll see like Netflix, there are many things that's happening in here. There is something called as Ribbon that helps you do load balancing, So this is more of a client side load balancing, and then the server side load balancing also happens automatically inside your microservices. Then you have something called a Zool that can help you do a lot of gateway routing rules. It's like a gatekeeper, where anytime any service calls comes in, it's like a check to say that, do you have access to this particular service? Oh, yes, you do. Route that particular call to that particular service. If not, stop it, and then monitor it accordingly. And then Hystrix is an implementation so that you can have better fault tolerance, and it lets you build a circuit breaker pattern where, after say you attempted calling your service 3 times or 4 times, and then on the 5th time, there's still no call for whatever reason, then you don't just throw an error message and then let all your other services, the top services where the information is getting bubbled up, just get that error message. You rather die gracefully. What does that mean is you actually pass a proper error message information, informing your services which are calling your services to say that, hey, these are the problems, this is what has happened, and then let that entire service call end properly and let your user get the correct information. Now, what's happening in the ecosystem over here with Spring Boot and Spring Cloud is you have your different devices like your IoT, mobile, browsers, and other things. Those are your users. They can interact with your Spring Cloud components. So the red blocks are the Spring Cloud components, which comprises of an API gateway like Zool, for routing rules and stuff. You can have a breaker dashboard like your Hystrix to monitor your services and see where you can implement your circuit breaker pattern. You can have a config dashboard where you define your configurations that your microservices need externally, meaning if anything has to change from a configuration point of view, you don't have to go and redeploy your microservices. You can just go and update it in that particular config server. And then you have a service registry where all your microservices, when they spawn up, they go and register to that service registry to say that, hi, I'm present here. These are my details. If any of the other microservices wants to talk to me, or is looking for me, please find it from the service registry and then route it through to me via the API gateway. Then you have distributed tracing enabled over there, so that how each individual services are talking to each other, you can track and trace all of those things from an auditing purposes. And then you can have varieties of databases or message brokers or anything else, in the backend to persist your data or to stream your data to do something. So in a nutshell, this is what happens with Spring Boot and Spring Cloud architecture. Where do you start? If you have to start in the Spring ecosystem, and I tend a lot of these questions all the time, and I suggest that start with the Spring framework first, because it literally gives you the entire foundation of what is happening. At the bottom of these slides, I've mentioned the actual URLs and information that you guys can look into. So that's the entire Spring details and why you have to make use of Spring. Then there are individual projects, that has been mentioned. These are the details that I've mentioned over here. So that start with the Spring framework, then move to Spring Boot. What Spring Boot basically does is that it follows convention over configuration. There are some de facto and default ways that developers have done things, and those are the best practices. So those things are already available to you out of the box. You don't even have to worry about it. You just spawn it up, start to write your code, and then execute it, and bam, your services are up and running. Then the Spring data part of things is quite important, so that you can interact with various kind of relational, non-relational databases, or if you have any kind of key value pair information, kind of a data persisting thing, you can interact with all of that. So this is basically Spring data basically is a wrapper around all of those databases, and it makes it easy for you to interact with any kind of databases rather than worrying about the plumbing work, to go and connect to each of them. And then Spring Cloud basically is all these other building blocks that we discussed in the previous slide that helps you coordinate well in your microservice architecture amongst your microservices. So please have a look to these particular URLs. There is a very good start here guide over here that takes you step by step on different kind of learning courses and stuff, different kind of Spring data JPA learning things. So you can just follow through these things, and in just a couple of weeks you can learn about Spring and what's happening in the Spring ecosystem quite well. This is an example, a very used example over the internet in terms of what happens in a microservice architecture. So this is related to a pet clinic, and in that pet clinic you just have 3 different services to say that who is my customer, who are the vets who are available to see the pets, and how many visits or something related to any kind of visit for your pets have been mentioned over here. And you will see that it's just a web browser basically that's available. From there is a RESTful call that comes in, and this is where your API gateway, or Zool if you are using Netflix OSS tech stack, helps you route to varieties of services. Now in the beginning what's happening is when your customer service, vet service, and visit services spawn up, they go and register themselves to the service discovery system, which is Eureka. And they just go and inform to say that, hi, I'm customer service, I'm available, please register me. If anyone else is looking for me, this is my address, these are my details. If someone looks up for me, send them and route them to this particular address or this particular URL. Now you can completely externalize your configurations also into Spring Cloud. And then you can have different kind of repositories available, like in your GitHub or any kind of other Git systems like GitLab or anything else that you're making use of. And you can configure all those things externally. Meaning, imagine in your customer service, you have a feature that you don't want to have it accessible right now on your production server. You can go and switch it off, from a configuration point of view, just to say that that particular service or information is not available or accessible, the value is false. And you can still have your code available in your service and just put a condition in the beginning to say that, okay, if this thing hasn't been enabled, don't let anyone access it. That's it. So you can do a lot of varieties of custom checks like these also. What is happening from a monitoring point of view is over here, where all your logs from varieties of your services, which are distributed logs, gets collected, using something called as Zipkin. Zipkin is another library, and you just enable it by writing one of the annotations from Spring to let all the logs get dumped into the Zipkin server, and then you can just have an admin server in the front called Spring Boot that lets you access all those logs and monitor it. Now there's a lot of moving blocks also over here, and that becomes quite challenging also to actually go and sort it out, like in terms of coordinating them and seeing how all these things are working together. And that's where cloud services play a very vital role. So now, before I jump into the cloud details, are there any other questions related to Spring ecosystem?
Saurabh, not really a question, but more a request. So GN McCuz is asking, would it be possible for you to share your slides with us?
Yeah, absolutely. I'll do so.
Okay, thank you. I'll ask Kevin to be in touch with you.
Sure. Cool. Just a very high-level architecture view of what's happening in the AWS ecosystem. Now, inside AWS, there are varieties of resources available. When I talk about resources, each of these building blocks, like Amazon CloudFront, Amazon S3, Application Load Balancer, Amazon Elastic Container Services, and varieties of data stores, each of them are treated as a service or as a resource inside the entire AWS ecosystem. Now, this is a very simple microservice architecture that I'm showing over here, where you have your AWS CloudFront for any kind of static content delivery. So that's just a content delivery network. You can host your website or something. Maybe you can dump all your website details, static pages or whatever it is, into a S3 bucket. Now, S3 bucket is just a document storage system where you can just put any kind of data information. Could it be a flat file? Could it be your website HTML pages, JavaScript pages, anything, files, anything that you can put in there. Your content delivery network, like Amazon CloudFront, interacts with it. Then it passes that call, from the user interface to your application load balancer. Now, the job of the load balancer is just to route your calls to multiple instances of your Elastic Container Services. Elastic Container Services are where all your microservices are sitting. Now, this is not just one instance of your microservice. There can be many instances of your ECS, provisioning your microservices, and your load balancer can literally just route to any of them depending upon what kind of routing rules have you mentioned on your ALB. And then individual services, microservices that you have built over here might be they might be interacting with your different kind of data stores, like your DynamoDB, which is a NoSQL DynamoDB database, or your Elastic Cache, which is more for caching purposes and stuff, or through Aurora RDBMS system, which is very unique and specific to the AWS ecosystem. So this was just a very high-level overview of what a microservice architecture would look like if you have to do it in AWS. Now, on the Azure front, Azure lets you do also microservices in varieties of ways. What I'm showing you over here is a very specific product or a feature from from Azure, called the Azure Spring Cloud. Now, the Azure guys, Microsoft guys, have partnered with VMware guys to build a platform as a service, and that's what is called as Azure Spring Cloud. Inside Azure Spring Cloud, under the hood, what's actually happening is, so imagine this is Azure Spring Cloud, that entire dotted block. You have a swarm of microservices, many microservices that can be provisioned in here. Do you remember the registry service that we saw in the during the Spring Boot and the Spring Cloud images, and also a suggestion in our microservice patterns to have a registry to register your services, a configuration server to externalize your configuration, and a distributed tracing and tracking server to have all your audit logs and other things available. Now, those things are already provisioned for you inside Azure Spring Cloud. You don't have to do anything. Underlining all your microservices and everything else that's happening inside Azure Spring Cloud is something called as Kubernetes. Kubernetes is a container orchestrator. Now, I've used two very profound words over there. Containerization is a concept of just taking your required artifacts and packaging them with the required libraries and dependencies that are needed for your application, and then so that it can run anywhere. When I talk about anywhere, meaning right now, a while ago, what used to happen was, I actually have a different slide for that. Maybe I should answer that then. I'm jumping off between my slides. Anytime when you had to provision an application, you need to have a physical hardware like your laptop. Then you need to have your operating system installed on it, that provides you with your kernel. Then you need to have your application layer, or different kind of systems like your application server or something available on it. Then you need to have your actual software application that runs or gets provisioned inside that application server. And then your application server was supposed to provide all sort of libraries and dependencies to your application so that it can run and function. And then your application was giving some sort of a user interface or RESTful APIs or services for your customer to interact with. Gone are those days. No one wants to build those services in that way anymore because it's very expensive. It's expensive to keep on provisioning physical hardware. It is expensive to keep on buying licenses for operating systems and stuff. Hence why people have moved to open source, which is everything Linux, or if you're using Unix systems, that's also okay. And now the underlining thing was the application servers and services around it. So hence why systems like Docker and few other things have come up, that lets you package those dependencies that your application needs and then let it provision and run it anywhere. Kubernetes, on the other hand, helps you orchestrate or manage those container images. Maybe it's related to Docker images. It helps you provision and it helps you manage all of them. That's what Kubernetes lets you do. So that's just in a very that's just the gist of Kubernetes, because there's many things to do and talk about it, which I don't think would be suitable for this session. So what happens from a Azure Spring Cloud point of view is, imagine you design your application using any kind of IDE like IntelliJ, Visual Studio Code, or anything else. You have your dependency management tools like Maven or Gradle to build your applications and stuff. You have your pipelines available like a CI/CD pipeline, and then your artifact was built successfully. Now you can take that artifact and deploy it straight as a Spring Boot application and have it up and running in literally a couple of seconds, using Azure Spring Cloud. Or you can follow something like, from the source code, you can create a source to image, container image, and then store it into Azure's container registry, and then provision that particular artifact from that registry and spawn it up into a Spring Cloud, into a Spring Boot application like a microservice over here. In the background, you can leverage on the same service registry and Spring Cloud config server to interact with. And then you can have varieties of databases that you have provisioned so that your microservices can work with them. So this is a very specific product or a feature inside Azure called Azure Spring Cloud that Microsoft has partnered with VMware to provide the power of Spring Cloud, the one that we saw over here, the red blocks, and make it as a platform as a service for Azure customers to leverage on Java onto the Azure platform. Guys, any questions before I jump into the final part of all of these?
No questions so far, but students, if you do have any questions, please do type them in. But in the meantime, please proceed.
Cool. Now let's just deep dive into some of the various other Java-based frameworks for microservices. Look, the fun part of being in the open source world, and I always mention this thing, that it's a blessing and a curse. It's a blessing because you have so much of information to work with. You have all these amazing power available to you that you can learn and just tap into and start building awesome solutions and stuff, right? And the open source community is amazing. I remember, like, I think around 15 or 16 years ago when I started writing plugins for Mozilla Foundation, like, the Mozilla browsers used to have all these plugins. I remember I was very nervous about uploading my very first plugin because I wasn't expecting anything to happen. And when I did that, I got a lot of good feedback and a lot of bad feedback also, because I had written one of the most worst extension that one could have ever imagined, not following any of the guidelines. And I was amazed that the open source community developers were so good that they guided me through all the mistakes that I've done, all the things that I haven't developed correctly. And they gave me enough documentation and information around how to fix it, sample examples. And then in a couple of weeks, I was able to rectify all my problems, learn the right way of building those extensions for Mozilla, and I was able to upload it, and it was successful. So that's the awesomeness of open source community. You can just go and ask, and someone will be there to help you and guide you. If not, they have already provided so much of documentation for you to just go through them and understand and build something of your own, or work in a collaborative way and share it with the bigger community. So let's just talk a bit about Jakarta EE and the Eclipse micro profile. Now, the Java solution has always been with Sun Microsystems before Oracle bought the entire Sun Microsystems company, and then Java became part of Oracle. Oracle was not able to manage many portions of the Java development processes for varieties of reasons and stuff. And finally, they ended up moving some of the Java EE, the enterprise edition part of things, to Eclipse Foundation. Now, when that happened, Jakarta EE was created, which is more of a guideline and specifications to say that, hey, these are the specifications following which you need to build things. That's it. Now, whether or not a system or a company follows those guidelines, it's up to them. But most of the open source community do follow the guidelines very well. If the guidelines are not right, they go back and discuss about it and they change those guidelines also, which is also good. Meaning there are teams available and people available to hear the problems and let it and solve them together, which is very good. Now, what happened with MicroProfile is when the Spring community and the Spring world literally took the whole world, in a swarm. Like I remember reading it somewhere. No, I think it was November 2019 or 2018 details. Almost over, I think 130 million downloads of Spring Boot artifacts have happened for development purposes, and majority, I think almost over 78, if not 82% of global enterprise systems make use of Spring Boot to build their microservices. Now, when this was happening, the Java world, the JEE world was still falling behind because no one was taking initiative to fix it. And then the MicroProfile team guys came back and said, guys, we want to build something similar to what Spring does, but follow the proper JEE standards. And they did it. So this is the fourth iteration, the 4.1 iteration of MicroProfile. And you will see each of these building blocks are different specifications and suggestions from Jakarta EE that MicroProfile teams have implemented, like to say that, hey, enable open tracing. So if you remember Zipkin in the initial slides and stuff, that's what open tracing is all about. Fault tolerance, that's related to Hystrix. If you have to look into some things like a REST client, so they're suggesting that follow the REST client version 2.0 guidelines to build your RESTful services. If you want to go and build a health system or a health check APIs, then go and follow the guidelines from Health 3.1. And all these things are, again, unique building blocks from your microservice architecture patterns to be implemented. And MicroProfile provides you with an implementation of those specifications. There is a lot of things to be discussed inside MicroProfile. I don't think we'll have enough time to do that, but if you guys have got any questions later on also, I think let's just collect all those questions and I'll be happy to.
Right, yes, so thank you. So the first question is actually more to do with your plugin. So S. van der Westhuizen wants to know what the name of it was, or simply what did it do? All right.
Sorry, which plugin?
The one you built. You mentioned it. Yeah, so they're interested. Students love knowing a little, your personal projects on the side.
Guys, it was, sure, that was a while ago. It was just an extension that I built. It was more of a download manager kind of a thing. I remember the initial versions of Mozilla Firefox, but it wasn't even called Firefox back then. It was just Mozilla browser. They didn't have those, the details for what I'm downloading or anything like that. It never used to keep a history or a record of those things. Look, now every single browser does that. So that's why it was a bit of a lame feature. But again, back then it was not available. And I was like, hey, what if I just go and build an extension for it so that I can see the history of all my downloads, so that I can go, because I used to download a lot of open source applications and softwares and whatnot back then and whatever other things. And I just wanted to keep a record of them to say, okay, what have I done? Because again, back then internet speed wasn't that great and you had limitations on your bandwidth and your data. It wasn't unlimited at all times. So you have to be very careful about what you're downloading, what's happening. So it was just that. I really don't remember the name of it right now. Sure. I don't even know where the code is. It was really a long time ago, guys.
Okay, and then the second question Kay Walker asks is, can Firebase host microservices? And then I'm just going to add the next one because we are running out of time. Jen Makaza also asks, what guidelines would you recommend to someone who is interested in diving into the open source world for their project as a first timer?
Okay, cool. Sure, sorry, what was the first one?
Sorry, yes. Can Firebase host the microservices?
Okay. So Firebase from Google Cloud Platform has got varieties of roles and services around it. Initially, when it was written for a different purpose in terms of scaling the data. As of right now, I think you can build, Google Cloud Platform has got another service called APIGEE, APIGEE. I'm just gonna, that's where your API management happens from the Google Cloud Platform. That's where you can go and build your microservices and provision it from an API point of view. Yes, you can connect that to Firebase. Whether or not it is hosted inside Firebase, I don't know about that because it's a Google proprietary thing. So I don't know if that actually gets provisioned inside Firebase, but APIGEE lets you do API management and do some sort of microservices that you can build in there that connects to Firebase. The next one was, what guidelines would you recommend to someone who's interested in diving into the open source world for their project as a first timer? Awesome, good question. My suggestion would be, find the right problem statement that is really irking you, meaning on an individual level. I can go and suggest I want world peace, but I don't have the means of providing world peace, you know that, right? So the best way would be, go and find the problem that is truly irking you or something that you want to build for yourself, and then look into how you are going to architect it and see what varieties of free open source applications, frameworks, and libraries are available. I remember a long time ago when there was a time when you used to make use of DVDs and CDs and other things like that, and people then started to collect everything like movies and other things like that and songs on your hard drives. You used to get these big 3.5-inch SATA hard drives, right? And then the 2.5-inch hard drives started to come back, what were introduced. I had around 5 terabyte of just hard drives, and I had so much of movies and songs and this and that in there that every time when I was to go look for something, I was like, okay, keep on plugging each of them, rename them properly, try to build some sort of index around it, but it was very difficult for me. So I picked up that problem so that, hey, how quickly can I just go and look for a song, maybe just by following the genre of that song and trying to find. And what ended up happening was, I spoke to some of my friends and some of the colleagues also, and they suggested to me saying that, hey, why don't you try to build a redundant array of inexpensive disks, like a RAID array, that you can just connect with your servers and stuff and plug it in. Then I was like, okay, cool, I can do that. I've done that before, but how do I build the software around it? And then after doing some sort of Googling and stuff and researching around it, I ended up finding Hadoop. So there's something called as big data, Hadoop. I hope you guys can see my screen. So Hadoop is also available. What's happening here? Apache Hadoop is an open source framework that is available from Apache, and I was able to use this to build a cluster, and dump a lot of my data into it so that I can do indexing well, and then I could go and find information around it. Little did I know that this is an awesome piece of application and software that is getting used by majority of the companies globally. Like, check here, Cassandra. Cassandra is something that Facebook makes use of. Behind the scene, it makes use of Hadoop. Spark. Spark is again used for varieties of data ETL for extraction, transformation, and logging and things like that. And you just start somewhere, you can just literally just Google about these things, or there are varieties of community forums that are available also, on which you can just drop a message to say that, hey, you're starting new, you want to learn about Apache Hadoop, this is your problem statement, could it help you, and then take it from there. Cool. Any more questions, guys?
I don't think any questions. You can continue. And Klaus, I know we are 3 minutes left, but Saurabh, you can continue and just finish it off, because I think this is very helpful to the students as well. So
Cool.
we'll go into my lecture. It's not an issue. Thank you.
Cool. Okay, thank you. Just on the Micronaut part of things, I remember using Micronaut for the self-driving car. Why? Because initially I built my RESTful APIs using Spring Boot, and then I was running it on Raspberry Pi. It ran well, everything was perfectly fine. only the context. When initially when my services were booting up, it was taking around 13 seconds. And for Raspberry Pi to take 13 seconds to boot up for a self-driving car, I think that's problematic. You want the image to be getting recognized instantly so that your car can move instantly. You know, it shouldn't be that it's taking some time, or a couple of milliseconds to recognize the image. That's okay. But if the boot up time is only 13 seconds, then my car is just literally standing there doing nothing. You know, so I started to look around to find different ways of JVM-based frameworks that I could use. You know, and then I ended up finding Micronaut, and I was amazed that how amazing this thing is in terms of the boot up time. So I rewrote all my RESTful APIs using Micronaut. I didn't have to change a lot of code because these are still following all sort of best practices and standards from your Java community and following the right sort of Jakarta EE specifications also. So literally it was just annotations and stuff that I had to change. Are you guys able to see my IDE?
Yes, we are. Thank you.
Okay, cool, perfect. So yeah, I just want to show a small piece of code over here. So this was when I presented it at DevConf. This is just literally just a my car application saying that, hey, Micronaut, run my application. And then I had to just build a RESTful controller over here, just a service to say that, okay, all calls coming to the root, direct it over here. And what is it that I want to do? I've just exposed a couple of RESTful endpoints with get HTTP type to say that for videos, call that service. For my PWM test, something else. When the car moves forward or backward, do something else. When it stops, do something else. When I steer, then give me the angle details back from it. And when I'm driving, I just want to collect, the drive details like angle, throttle, and few other things around it, and then just get it back. And this entire thing makes use of Micronaut to run the thing. Sorry, I'm just checking something quickly. Browser is hanging a bit. So yeah, this was just very straightforward implementation by using Micronaut, and I was thrilled to see its performance on Raspberry Pi. It was literally like a couple of milliseconds, and the context was up and running. My RESTful APIs were up and running, and I could just call it and access it through a web interface from my laptop, which was just connecting to localhost. So Micronaut is something that you should look into. Let's just run quickly through Quarkus. Quarkus is something very new to build proper cloud native applications. It's supposed to be super fast, very small, and it is literally leading the way for Java to now become a very de facto standard even in the cloud native space. Now let's just discuss that quickly as to why. We have seen that there is monolith architecture. Microservices is what we have been discussing. Serverless is something that we saw on one or two slides. Then event-driven architecture was around the pub-sub mechanism, the publishing and the subscribing of things. Cloud native is when you want to run your entire application into a cloud instance. But the challenge that has started to happen in cloud instance is now, so historically, the Java stack used to be this, which is what we discussed. You have your operating system and hardware, you have your Java virtual machine, then you have your application server, then you build some sort of dynamic applications and stuff, deploy it in there, and then you have your varieties of apps around it. This was the historical version of how Java stacks used to be getting used. Now everything gets provisioned through containers, like your Docker containers, and you have Kubernetes to provision and manage all those images and containers for you and run it in a Linux server. But what hasn't changed in this modern tech stack is that you still have that JVM application server and the dynamic frameworks available for your app. The only thing that has been shrunk is to say that, hey, all these dynamic libraries or something else that you need are not needed now. You can just throw them everything with your app, or your Docker container is actually going to hold all those libraries and make use of them. But this block at the bottom hasn't changed. And that's where the problem starts when you're running a serverless application. So what happens in a serverless application is that you're not managing the server. So the moment when your code gets deployed, you start it, it takes some time to build that context, and then it runs. And then when you switch off that particular function, it dies or it stops. All that time and processing power gets calculated by your cloud provider, and they bill you to millisecond detail of it. And sometimes these things can become expensive. Imagine if you just want to call that service for 3 milliseconds and get the job done. But in order to start that service, it's already taking 5 seconds. Now you're paying unnecessarily to your provider for those 5 seconds to spawn up and start it up, isn't it? it's a waste of time and money and resources altogether. So hence why Java was slacking a bit in that, just because of the way the JVM has been created and things like that. And Node and Python and Go, they were taking the step ahead around it. This was in 2018 or so, but the entire thing has been literally changed, all thanks to Quarkus. Quarkus is a framework that has been designed by the Java guys to be completely cloud native from day one. So that doesn't matter if you are deploying it or running it via Kubernetes, Istio, or Knative or something like that, it will still run properly, and it has been designed thinking serverless and cloud native in mind. So what exactly is Quarkus doing right now is literally replacing the entire need of a Java virtual machine to spawn up something. And what it does actually is it reduces, and that's why the name subatomic and supersonic has been given to it, where you see over here a traditional cloud tech stack when you just had a RESTful API. So meaning you just have exposed a RESTful API, it's not even doing any kind of IO operation to your databases or anything like that. It used to take around 140 MB of memory just to spawn it up. Then when you had Quarkus plus your OpenJDK JVM, which is the default JVM that comes, the default JVM is Hotspot that comes prepackaged in your Java development kit. But you can change it to OpenJDK that comes from Eclipse, and it was still taking 74 MB of your memory. Now with something called as Agrawal VM, which is what Oracle and many other companies are working together with, the entire thing is now just taking 13 MB in terms of your memory utilization. Similar thing was seen in terms of having a RESTful API and doing IO operations, where you can see how drastically using this, it has just reduced the entire memory utilization while still providing the same services that your user interface or your client or any other third-party system wants to integrate with. So now the new truth that has happened is, regardless of what kind of container orchestrator you have, like Kubernetes or anything else that you have in here, other programming languages like Go and Node.js used to provide that you can scale very quickly and you can have insane number of instances of them. Traditionally, the Java stack was very difficult to do so, but with Quarkus now, on that one same compute node, you can have many instances of your services up and running spontaneously, and which is utilizing your resources less, it is spawning up quickly, it runs fast, and this is where the startup time difference, as you can see. When you just had a RESTful service, a traditional cloud native Java tech stack used to take 4.3 seconds. Same thing in Agrawal VM takes like 0.014 seconds. So what's happening now is that your startup time is so fast, your resources that it needs is so less. So you can actually have more services running much more quicker in very little resource, or RAM that you need to provision them. So you're not paying unnecessarily for anything. You are spawning up your things quickly, using them, shutting it down quickly as you need them. Same thing with the CRUD IO behavior that you're seeing over here at the bottom. And that would be it, guys. That's all from my side.
Thank you very much, Saurabh. So one final question from Kay Walker, and it relates to the project, your car project. So does the API make the decisions on how the car drives?
No, it doesn't. I had trained a CNN model separately, and then whatever was learned out of the convolutional neural network model was getting used to decide how the car would self-drive later on. The API was just there for me to interact with the web page that I had, so that as I'm steering, because what I had was I had a PS4 controller that I had used via Bluetooth to connect into the car. And then I used to train the car how to drive, like manually drive it first so that it can keep on processing the images, understand different tracks and paths and other things around it, and then learn from it. And then the training part of the model and other things was done separately, because you need resources and performance, and power to process all those details. And then once that training was done, and then I used to feed it back and into the self-driving mode basically, and then it used to, whatever it has learned from the previous driving experiences, it used to try to follow them differently at different instances and self-drive itself. But the API didn't have anything to do with that.
All right. There's just a follow-up about how much test data did you use for training your model?
Sure. It was a lot. And that time I didn't have, I should have actually trained it inside the cloud instance if I could have done. And there was a NVIDIA cloud option available, but it was crazy expensive to actually opt for. Just in terms of a couple of hours of training would have cost me literally an arm and a leg. But in terms of training data, what I did was the images that the camera was capturing, it was just a Raspberry Pi camera. So it used to capture 120 by 160 pixel images, just a black and white images and stuff. And in a couple of, I think I used to drive in that one track. It was just an oval track that I had. I had collected around 60 to 70,000 images just in like a couple of minutes of driving. And then I used to take it back because remember all these images were getting collected on the Raspberry Pi, and Raspberry Pi doesn't have that much of power to process anything on it, let alone store it also, And it was just one Raspberry Pi, and I was using that. And the processing was getting done it was actually my work laptop on which I was running the entire TensorFlow neural network thing to process it and learn from it. So yeah, I had different sets of data. The initial ones were quite bad because I didn't realize that I was collecting a lot of noise and few other things, and so I had to clean it up, I had to fix it, and then train it back.
Okay. Yeah, these students don't want to let you go. Follow up to that question, just for clarification, wasn't your testing using AI? That comes from GN Makaza.
Well, yeah, so that's why I was making use of TensorFlow in order to build the CNN model quite well. So the CNN model was available. TensorFlow provides you with some sort of libraries and processing thing inside it. So I was making use of TensorFlow so that it can learn from those images and understand that, hey, what is a path? What is a obstruction? What happens if the path is a bit different? In which angle the car has to steer? That's why in that code there was details about throttle, about steering angle, left and right. One thing that I wanted to try was to drive the car in a reverse way, but I didn't have a camera at the back, so I didn't collect that detail, or else I should have done that.
Thank you very much, Saurabh. I think S. van der Westhuizen had the best way to sum up how we all feel, but thank you so much for the very clear explanations. He loved the visual connections that you've clarified between the different technologies, and he would definitely rewatch this presentation. Jay Malachi says the same. So you've made this recording very, very well worth their while. Thank you so much for spending a little extra time. I know you went over time. You committed to a double period, and you now went over. We really appreciate your all the information you've provided our students, and we really appreciate the support from DVT. So I'm sure they all would applaud if they could. But thank you, Saurabh.
No, only a pleasure, guys. Thank you.